Okay, good afternoon class. So today we're looking at trigonometric ratios, chapter 7. So we're going to just do some revision of grade 10 work. Okay, I'm just going to pause the video. I don't want the video to be too long. Okay, we're going to run through the basics quickly. Alright, so we're back. So the full lesson can be found in the description box below. Okay, so we said that in the first exercise, or this first lesson, we're going to look at a brief overview of the general trigonometry covered in grade 10. So I'm looking at example 1. Example 1 is on page 223. Alright, please settle down. The girls playing musical chairs at the back. Why are you sitting there today? You can see better from the back. Okay, let's tell ourselves that lies and we'll start believing it. Okay. But anyway, the question is, in which quadrant does x lie if tan is greater than 0? We just mentioned now, if tan is greater than 0, what does that mean? That is positive. And cos is less than 0, which means to say it is negative. What quadrants are they referring to? At all stations to Claremont diagram. Okay? Remember, this is 0. This is 90 degrees later, which makes it 90. 90 degrees later, 180. 90 degrees later, 270. 90 degrees later, 360. You see that, people? And we said this is going to be A or S. What does S stand for? Sign. Only sign is positive. All stations still clear one. So what does T mean? Tan. It's positive, and yeah? Cos. Cos is positive. Which means to say if you get sin, tan or cos in the second quadrant, it will be negative. Cos and sin in the third quadrant, negative. And cos in this quadrant, positive. This is then known as quadrant 1, 2, 3 and 4. You all agree with that? So this is tan is positive. Tan will be positive in 2 and negative in 2. Sin will be positive in 2 and negative in 2. So will cos be positive in 2 and negative in 2. You guys understand? So for us to determine one of the 4 quadrants, I need 2 pieces of information. You guys understand? Because if you only give 1 piece of information, then this would lead you into 2 quadrants. You see that? So we ask ourselves, okay, which quadrant is tan greater than 0, which means to say tan is positive. So where is tan positive? Quadrant 1 and 3. Okay. The second part of the information is, where is cos less than 0? What does less than 0 mean? Negative. In which quadrant is cos negative? Quadrant 2 and? So in which quadrant do you think it's going to be drawn? So therefore, the third quadrant. Okay. See any confusion at this point? No. Let's look at example 2, the second example. Also on page 223. Here we are told if 13 cos alpha plus 5 is equal to 0. If 13 cos alpha plus 5 is equal to 0, and sine of theta is greater than 0. What does greater than 0 mean? Positive. Determine, without the use of a calculator, and normally it says with the aid of a sketch, the value of 13 sine alpha minus 5 tan alpha. Okay. So where do we start? We need to determine in which quadrant it is in. Not so. We need to determine which quadrant it is in. So if we take 13, cos alpha plus 5 is equal to 0. So what I'm going to do is, I'm going to make the trig ratio the subject of the formula. Or in this case, I'm going to make cos alpha, the subject of the formula. And how do I do that? Negative 5 over the equal sign. So it's going to be 13 cos alpha equals negative 5. Now what do I do? Sorry? Divide by 13 both sides, not so? Right. So we divide by 13 both sides. And what do I have? Cos alpha is equal to negative 5 over 13. So what does this tell us now? That cos is negative. What? Oh, it's an alpha, no? Right. So now, before we draw the diagram, we need to determine in which quadrant this diagram lies in. How do I do that? I go to the cos diagram. Okay. Comes the cos diagram. So we ask ourselves, the question we ask ourselves, in which quadrant is cos negative? In which quadrant is cos negative? Quadrant 2 and 3. Can you see that, people? But this tells us that sine is greater than 0. So sine is positive. In which quadrant is sine positive? Quadrant 1 and 2. So in which quadrant would we draw that in? Quadrant 2. You guys understand? So let's draw it in quadrant 2. So I draw the terminal arm there. Then I drop this perpendicular onto the x-axis. And of course the angle will always open from this positive x-axis onto the terminal arm. Okay, and that's your alpha angle. Okay. So what does this say? Cos of alpha is negative 5 over 13. Well, remember, I got negative 5 over 13. That is the same as 5 over negative 13. You all agree with that? Which is the same as negative 5 over 13. All of that is the same. Okay? So when I plot those lengths on the diagram, what does cos stand for? Opposite of hypotenuse. Adjacent of hypotenuse. Opposite of hypotenuse is? Sine. Okay. So it's adjacent of hypotenuse. So we use this as my reference angle. Can you see that? So the adjacent is 5 and the hypotenuse is 30. But what do we notice? This is on the negative part of your x-axis. So that negative belongs to the 5. This 13 will never be negative. Why? Consider as a length of your hypotenuse. You guys understand? So what still needs to be solved in this triangle? I need to work out the opposite. Why? Because our sine is opposite of hypotenuse. Can you see that, people? Huh? Yes, this is O, yes, absolutely correct. O. For opposite. Okay. So how do you calculate the opposite? Pythagoras, yes. So 13 squared is equal to O squared plus negative 5 squared. What is 13 squared? 169 is equal to O squared plus 25. We get over the equal sign. So 169 minus 25 is equal to O squared. O squared works out to be 144. The square root thereof, your opposite is 12. Okay. Have you answered the question? What was the question? They want 13 sine alpha minus 5 tan alpha. There we go. 13 sine alpha minus 5 tan alpha. What does sine stand for? So that's my reference angle now. So my opposite? 12 over 30. That is what sine is. You see that, people? That must be multiplied by 30. Minus 5 into. Tan is opposite over adjacent. So this now gives us that cancels. 12, negative times negative is positive. 5 cancels 12, and 12 plus 12 is? You guys understand? Let's do it again. Rather Billy? Absent. So you all understand, eh? So right, remember this is your first question in trigonometry is like this. Okay? You must get this right. It's also your first question in your upcoming cycle test. Right, so let's look at the next question. Please settle down. 224. Example 3. 224. Without the aid of a calculator, determine the value of the following. But remember, last year when we did the special angles, we drew the following. This is 30, this is, what's this length? 60, yes, but the length 1, 2, root 3. You're mixing up your two triangles, Michael. That is your isosceles triangle. That will be 1, 1, square root 2, that is 45. Then this is not a triangle. And don't prove to me it's not a triangle, because I know it's not a triangle. But it works for what we're looking at. That is 0. That is 0. 1. That works. Okay. So if I look at A, the one sine squared 60 plus sine squared 30. Sine squared 60 plus sine squared 30. So what does sine stand for? Opposite over? Hypotenuse. But there's 60 degrees. So there's 60. Opposite is? Root 3. So it's going to be square root 3 over hypotenuse, which is 2. Square plus. Now you see it's 30, sine of 30. This is your 30 degree angle. What does sine stand for? Opposite over hypotenuse. Do you see that? So it's 1 over 2. So what's the root of 3 squared? 3 over 4 plus 1 squared is 1, 2 squared is 3 plus 4, 3 plus 1 is 4 over 4, which is now you guys understand? So any confusion there? B. Again, without the aid of a calculator, determine the value of the following. So sine of 30. Sine is opposite over hypotenuse. So it's 1 over 2 times. Tan of 45. Here's your 45 degree angle. Tan is opposite over adjacent. So it's 1 over 1. Sine of 90. Here's 90. Sine, what does sine stand for? Opposite of hypotenuse. 1 over 1. Over. Cos of 60. What does cos stand for? Adjacent of hypotenuse. So it's 1 over 2. Half goes into half ones, so half goes into half ones. So it's simply 1 over 1. You all agree with that? Choose an answer. Is there any confusion there? Okay. So with that, you should have been able to do exercise 7.2.